Hello students, now in this video we will discuss bar magnet as equivalent solenoid. Hope you all know about solenoid. Okay. Now what is bar magnet? Bar magnet is a simple magnet that is a uniform cross sectional area. This bar magnet is cylindrical. Okay. This is cylindrical and radius of that bar magnet is A and total length is 2L, and from the origin it is L. Okay, and we have to calculate magnetic field at that point, and the point is at R distant from the origin. Okay, now consider this bar magnet. This is bar magnet, not solenoid, but consider this bar magnet as a solenoid. Okay, means the wire is wounded on the bar magnet. Take only dx thickness on the cylinder or on the bar magnet, dx. In dx thickness, let us suppose this is the dx thickness. Okay, there may be a number of wires, but we don't know. Okay, let us suppose n is what? N is the total number of turns per unit length. Length of the bar magnet is 2L. Small n is the total number of turns per unit length. If you need total number of turns, then capital N equals to n into 2L. If you need to calculate the number of turns in the dx length, then the number of turns in the dx length will be this only. Okay, now let us discuss some points. First point, on the axis of the coil, magnetic field is mu naught upon 2 Ni A square upon x square A square to the power 3 by 2. This is the magnetic field on the axis of a coil. If this is a coil and this is the this distance is x and the radius is A, then this is the formula. This formula is used. Similarly, we will use this strip as a coil. Only one strip, dx thickness, is a coil. Okay, and this coil will produce a magnetic field on p axis. Okay, now let us try to write the formula for this particular dx length. Okay, mu naught upon 2 Ni is the total current. Okay, now here number of turns is in the dx thickness, number of turns is n dx, and the current in that wire will be n dx into I, means total current in this coil will be n dx into I. This is the total current, means in place of Ni. A square is A square because the radius of the solenoid is also A. Okay, now x is what? X is the distance of that point from the center of the coil. But this coil has center at this point. Okay, at this point. Now the distance we have to put here, in place of x we have to put here what? The distance of the center of the coil from that point, means this distance from this point to this point. Okay, this distance is what? Total distance from the origin is R and this is x. That means this should be R minus x. In place of x we will write r minus x whole square plus a square radius square whole power 3 by 2. Hope you are understanding. Now this is a small magnetic field. Why? Because we have taken small strip. Okay, if you integrate for whole total magnetic field, dB is equals to, constants are mu naught by 2 n dx. Dx is not constant, n I a square upon. Here it is a condition, if r is very greater than x and also r is very greater than L, means that point is farther away, then x and a will be 0. R to the power 2 to the power 3 by 2 means denominator will be equals to r to the power 3, and r is also constant, then r to the power 3 is constant. Integration dx. Dx, what will be the limitation of this dx, of this integration? Dx is varying from minus L, this is minus L because it is here, and this is plus L because okay, means dx will vary from minus L to plus L, minus L to plus L, and integration of only this thing, integration of only this thing, integration of dx is equals to what? Only x. Okay, minus L to L. Here put the limit minus L to L. Put limits L minus L means plus L means 2L. Integration of dx minus L to L will be equals to 2L. In place of this you can write B is equals to mu naught by 2 n I a square upon r cube into 2L. Hope you are understanding. Okay, now magnetic moment. Magnetic moment, you know that total number of currents into area. Total number of current in whole the bar magnet will be equals to what? Whole current means total number of currents means capital N into I, total number of current multiplied by current, total number of turns multiplied by current, and area is what? Pi a square. In place of n you can write n into 2L, n into 2L into I into pi a square. This is the magnetic moment, and try to introduce magnetic moment in this formula. Okay, now B is equals to mu naught by 2 Ni into 2L, n into 2L into I, n into 2L into I into a square upon r cube. You may multiply pi by, why? Because it will become, this whole term will become m, and if you are multiplying by pi, also divided by pi, it will be equals to mu naught by 2 pi into m upon r cube, where m is the magnetic moment. This is the formula. This formula can also be written as B is equals to mu naught upon 4 pi, because mu naught by 4 pi, we know the value of mu naught by 4 pi. Okay, 2m upon r cube. You know that this is the formula to calculate the magnetic field on the axis of the bar magnet. Okay, axis of the bar magnet. if you compare electric field 1 upon 4 pi epsilon naught 2p upon r cube, this is the electric field on the axis of an electrical dipole. Electric field on the axis of an electric dipole, 2p upon r cube, where p is the electric dipole moment. Here similarly, in magnetic field at an on the axis of an bar magnet will be equals to mu naught by 4 pi 2m upon r cube, where mu naught by 4 pi is a constant for magnetic field and 1 by 4 pi epsilon naught is constant for electric field. Okay, here on comparison we can say that a bar magnet will act as equivalent solenoid. Okay, now we can say that mu naught by 4 pi in magnetic field or in magnetism and in electrostatic, it will be analogous to 1 by 4 pi epsilon naught. Means 1 by 4 pi epsilon naught is analogous to mu naught by 4 pi in magnetism. Okay, hope you are understanding, and thanks for watching this video.